Welcome back to the Math Mindset. Today we'll be looking at problem 9 from the 2008 AIME I exam. There are 10 identical crates, each of dimensions 3 feet by 4 feet by 6 feet. The first crate is placed flat on the floor. Each of the remaining 9 crates is placed, in turn, flat on top of the previous crate, and the orientation of each crate is chosen at random. Let m over n be the probability that the stack of the crates is exactly 41 feet tall, where m and n are relatively prime positive integers. Find n. Okay, so just as a general rule, we know that the probability, of anything happening, is successful outcomes, right? The number of successful outcomes by the total outcomes, by the number of total outcomes, right? So if we find both the number of successful outcomes and the number of total outcomes, we can find the total probability. So let's try and find the total number of outcomes. Well, the total number of outcomes is just the number of ways we can arrange the 10 bricks, so that each brick might have a different height or the same height. So for the first brick, we have three different options for which dimension to choose as the height of the brick, because that's what we're considering in the problem. So there's 3 choices for the first brick, and then again 3 choices for the second brick, and so on and on until we have 3 choices for the 10th brick. So there's 3 to the 10th total possible outcomes. So let's replace our total possible outcomes with 3 to the 10th, because that's our total possible outcomes. So now we need to find our successful possible outcomes. So we need to count up our successful outcomes. So how many successful outcomes do we have? Well, in order to start counting that, we need to find what combinations of blocks with 3 feet, 4 feet, and 6 feet add to 41 feet when they're stacked on top of each other. So let's denote A to be the number of blocks with height 3 feet, right? B will be the number of blocks with height 4 feet. And C will be the number of blocks with height 6 feet, right? So let's write a systems of equations, or maybe just one equation if we can, and see how we can work from there. So we know that the total number of blocks with height 3 feet, 4 feet, and 6 feet is just 10. So A plus B plus C is just 10, right? That's just equal to 10. And what should the total height of those 10 blocks be? Well, the problem tells us it should be 41 feet tall. So since each block in the A category is 3 feet, we have 3 times A plus 4 times B similarly, plus 6 times C, right? That's just equal to 41, right? So now we can try and solve these two systems of equations that we have. A plus B plus C is equal to 10, and 3A plus 4B plus 6C is equal to 41. Well, notice that in equation 2, just marked it down, we can probably take some mods to find possible values of B, just ignoring the first equation. So what I mean by mods is we can look at the remainder that B must leave when divided by a certain number in order to find out what B could be. So if you look at 3A and 6C, we know that they're both divisible by 3, right? divisible by 3. So the nice idea that comes to us is that we can take equation 2 mod 3. And when we do that, we get 4b, right, 4b. The 3a and the 6c terms vanish when we're taking it mod 3 because they're multiples of 3 anyways, so we don't need to consider those. Is congruent to 41 mod 3, right? So 4b, when we simplify this modular congruence, we get 4b is equal to 2 mod 3. So b is congruent to 2 mod 3, right? So if b is congruent to 2 mod 3, what are the possible values of b? Well, b can be either 2 plus 3, which is 5, or 2 plus 2 times 3, which is 8. It can't be any higher because the next value for b is 11, and that would mean we need 11 blocks with height 4 feet, and that's impossible because we're only given 10 blocks. So these are our only possible values of b underlined here. So now we can split this up into different cases to find all the possible values of arrangements for blocks with height 3 feet, 4 feet, and 6 feet. So our case 1, right? B is equal to 2, right? When we look back at equations 1 and 2, right? Let me just copy and paste it as a nice visual reference. Let me just copy and paste it. There. Let's move this here, right? We can make some substitutions. So because we know that b has to be equal to 2 in this case, we know that a plus c, right? Let me actually color code that. A plus c has to equal 10 minus b, or 10 minus 2, which is 8. And 3a plus 6c must be equal to 41 minus 4 times 2, or 41 minus 8, or 33, right? So we have these systems of equations with a and c, 2 variables, 2 equations. We got this. So we can divide this equation by 3 to get a plus 2c is equal to 11. So we know that a plus 2c is 11, a plus c is equal to 8. We can subtract these two equations to get c is equal to 3, right? So if c is 3, then a is 5, and b is 2, right? So this is one possible solution. Now we move on to our second case, or rather our second value for b. So let's say case 2. B is equal to 5. Now doing the same substitution and then elimination tricks we did above, we can say that a plus c, right, a plus c has to equal 10 minus 5. So a plus c has to equal 5, and then 3a plus 6c, right, has to equal 41 minus 4 times 5, or 41 minus 20, or 21, right? So when we divide this equation by 3, we get a plus 2c is 7. So when we subtract this equation and this equation, actually let me just write it down so that you can see it better. So you can immediately find the value of c. So we know a plus 2c is 7, a plus c is 5. Subtract c is 2. Right, so we know c is 2, b is 5. So a must be 5 minus 2, which is 3. So this is our second set of combination solution for the problem. And now we move on to our final case. Case 3, b is 8. So in that case, a plus c would have to be 10 minus 8, which is 2. 3a plus 6c must be equal to, right? 3a plus 6c must be equal to, let's see, it must be equal to 41 minus 4 times 8, which is 9. So when we divide this by 3, again we get a plus 2c is 3. So from that we know c is 1, because if we subtract like we did in the previous two cases, we get c is 1. So if c is 1, then a is 2 minus 1, which is 1. So a is 1, b is 8, and c is 1. Right. So we have our three cases. Now all we need to do is count the number of ways in which they can happen. Right. So let's write down our three cases in the form ABC, like ordered pairs. So we have three possible solutions. We have 1, 8, 1. Let's check the other two. What was the second one? 3, 2, 5. Wait, 3, 5, 2. 3, 5, 2. And then what was our first one? 5, 2, 3. 5, 2, 3. Now we just have to count the number of ways that either of these cases can happen. So let's look at the first case. We have one block with height 3 feet, 8 blocks with height 4 feet, and one block with height 6 feet. So this is equivalent to the number of ways of rearranging the letter sequence A, B, 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 C, where this part has 8 B's, right? We're just using, instead of dimensions, we're using letters in place of them. So the number of unique arrangements of that letter sequence is just 10 factorial, because that's the number of letters, or divided by the number of repetitions of each letter. 1 factorial, 8 factorial, and 1 factorial. This is equal to 90. Right? And the same methodology applies for the other two cases. So the number of ways of ordering this sequence of blocks is 10 factorial by 3 factorial, 5 factorial, 2 factorial. This is equal to 2,520. Right? And the number of ways of ordering the third solution, the third set of blocks, is 10 factorial over 5 factorial, 2 factorial, 3 factorial, which is the same as the case above. It's just the terms in the denominator are in a different order, but it's the same answer, 2,520. So when we add all the cases, so our number of successful, outcomes, right, is just number of successful outcomes. This is 2,520 plus 2,520 plus 90. This is 5,130, right? And using our probability formula above, we know that the total outcomes is 3 to the 10th, and our successful outcomes, well, we just counted that, it's 5,130. So our probability is just 5,130 over 3 to the 10th. But we can simplify this. Well, in order to simplify this, we need to find common factors that the numerator and the denominator share. So let's do that. So 5,130, let's try and factor that. So we can immediately pull out a 10 because this ends in a 0. So it's just 10 times 513, right? This can be broken down into 3 and 171, which can be further broken down into 9 and 19. So 5,130 is, in prime factorization form, 2 times 3 times 9, which is 27, which is 3 cubed, times 5 times 19. So let's write that up here. So this is equal to 2 times 3 cubed times 5 times 19 divided by 3 to the 10th. Aha, we can cancel out the factors of 3's from the numerator. So this vanishes, and this 10 turns into a 7 because of exponent rules. So the probability is just 19 times 5 times 2 over 3 to the 7th, which is just 190 over 3 to the 7th. Right? And what does the question want? The question says find m. M is the numerator. So we can just write the numerator as our answer, and we're done. So the final answer is 190. I really hope you enjoyed this video and you had a fun time learning how to solve this problem with me. If you learned something new, please don't forget to like this video, share your thoughts in the comments down below, and don't forget to subscribe. And I'll see you in the next video. Until then, goodbye. In the meantime, check out this video, or if you have the time, check out that playlist. But don't forget to subscribe.